All right, welcome to Lab 9. Get even more official with the welcome now that we're recording, right? So what we've got this full PowerPoint explaining how to program the lathe part step by step. I'm probably gonna just look at it right now for a second with you, and then I'm not gonna go back to it, kind of like I do. I'll probably go back to it at least once or twice. But we're going to basically look at this part and what type of raw material should we start with? Anybody? Like looking at the part? Not a square. Nico, you're correct. Circle, round. What diameter though? Ooh, right. So what's the max diameter it's got? So let's start with 1.5. Sound good? 1.5. And does everybody see it's 3.75 long? We good? But if you remember, that's the part's length. So if we have the chuck, got multiple colors, might as well do it. So then I got the part sticking out of the chuck right here. I got to get my tool back here to part off. So we can't just stick out like 4 inches. We're gonna go basically, we're gonna stick out, we're gonna have an extra 0.5 of an inch back here before we part off, just so we don't run into this chuck. Sound good? Yeah, hold on. We're getting there. So 3.75 right there. We're gonna go 4.25. We're gonna call the 25 thou negligible. It'll end up being by 4.975. Sound good? Any other questions? So we know what our material is. Now, the tool paths, what do we got to do in order to make this part? If we start off with a big piece of stock like this, what's the first thing that we're probably going to do? Oops. Yeah, we're going to qualify it. We'll face it. What else do we got to do? We got to kind of rough the profile out. So we're going to rough turn. Then what do we do? Finish turn. Okay, cool. After you rough, you finish. So I was trying to say. Then we got we got the whole thing kind of roughed out. What are we missing? Grooves. So grooves. Now it's like this really cool walking stick, right? It's on a 3 foot piece of bar stock. What do we got to do? Part off, so we just have the piece, not the walking stick. Bad joke. So part off. Now, while we do this, when we rough turn, we're going to split it up into basically two tool paths. So we're going to do one with undercut. Oh, no undercut. I call it undercut. They call it plunging as well. And then one with undercut. Just to show you the differences of how that works. Sound good? By then you can pretty much make anything you want on the lathe. Sound good? Make whatever you want within reason. Cool. So now, how many tools do we need to get this done? We learned about tooling for lathes. What's the most common lathe tool? The 80-degree diamond, which would be basically CNMG, whatever. It's the C shape. That's what we care about, right? So we're going to use the 80-degree diamond to face. We're going to use it to rough up here with no undercut. It's too blunt to undercut. Fair enough. Then what's the most popular finishing tool? Yeah, so the V, I'm just going to write NMG because that's the insert we have. But the V is what mattered. It's the 35-degree diamond, so it's sharper diamond. It can get into stuff better. So we're going to use that we're going to do 35-degree to undercut that's like the little radius in the back of the part. Show you that. Then we're going to finish turn with the 35-degree diamond. Next, we're going to groove. This is the one thing that the thickness of the tool might change. We're going to go downstairs right after we program. We're going to set up and run this. I might tell you a different thickness. Right now, it says that we have a 125 grooving tool. I think it might be 95 thou. So that's only a parameter you change in your master cam. If you didn't change it, your grooves are going to be the wrong size. Big deal. If you did change it, they'll be the right size on the first article. Sound good? I'm not worried about your groove coming out a little bit wrong size. I care about you understanding how the whole process for programming works. So we'll groove it with a 125 grooving tool. Now, the part off tool is a little bit different. That one's definitely a 125 fit. And so we'll part that off. So that's kind of what we got going in terms of tool paths. Is everybody good? Cool. So now that we have lathe diameter coordinate system. So what I'm going to do is I'm going to basically not come back to this. I'm going to show you how to bring in your model. I'm going to show you how to change the coordinate system from a mill to a lathe in terms of like that's the geometry. And then we'll go ahead and make our part. Cool. So we'll move back over here. Are there any questions? No, we're doing good. So there. Thought I had Mastercam open. I do. We are good to go. So we've got brand new Mastercam file. Just went file new. This is what I've got. How do I get my model in here? Yeah, so file open now at this point. So we're going to open. I'm going to go to computer, browse. I'm going to go right over. Ooh, I think mine's over here. Give me a second. Was it week 8? Week 9, I have mine in. I look for my SolidWorks files. There it is, project 3. And I press open. Comes in all shiny. Wait, no, I don't like. I'm gonna make it shiny. Hold on. There's a way to make it look chrome. I know. You're like, what is he doing? So this is really annoying, the zoom control. We're gonna throw that down here. So there's let's see here, material. There we go. Way better, right? So I just have it the material look, made it chrome looking. Now, the thing with lathes, we're missing a third dimension. We only have 2 axes, right? We have X and Z. So the first thing we're going to want to do when we bring our part in is align it to the Z axis. Why do you think that'd be important? So it's oriented the right way, right? Which way does the Z axis point down? Which way does it go? Down the part. Right now, it's not aligned like that. It's just whatever you modeled it in SolidWorks, it's aligned. Fair enough. Now, before I align everything, I just want to show you there's planes. Well, I opened 2026. You all right with that, or do you want me to go to 2025? Because this just looks different, that's all. But it's like, so it's literally the same thing. Sound good? But you have the older menu. So what I've got is, that's the cool thing too, is you can run both on one computer. So what I can do is I can go ahead. Give me a second. I gotta grab the lathe diameter plane real quick. So let me see here. Where did it go? C plane. Lathe planes, they're hidden now. It used to have it's 2025. It's its own thing, isn't it? It has this little drop out that looks like a lathe and a tool. Did you find it in 2025? It's right next to it, right? That's why I couldn't find it at first. You saw me tap dancing for a second. So we are going to do D positive, Z positive. Why is it D? Does anybody know? Diameter. So if you're lathe programmed in radius, it would be the X positive. But we don't program in radius, we program in diameter, so that's why they call it D positive. So we're going to do D positive, Z positive right there. And that's going to set up a plane, a lathe plane for us. Is everybody good? It's this, see, yeah, I think we're good there. I'm going to call it, I'm just going to leave it D positive, Z positive. Okay. So now when I go to model prep, I got to make sure that everything's aligned to that plane. So does everybody see where it says align to Z? Right up there in model prep. We're going to align our model now, just so the Z axis is along the length. So I'm going to align to Z. So here you could create your own brand new work coordinate system, or just we're going to align it to which plane do you think? I hit the button and I pick my D positive, Z positive. Does everybody see that? So we're going to align that to that. Select the solid to center on the Z axis. Any of these would work. Does that make sense, everybody? It's going to align the center of the solid to that z-axis. So I'm going to just pick the back of the part. Bloop. Now, here's the problem. There's not a problem. Does the z pointing the right way? So the z's not pointing the right way, is it? So what do I do? Bloop. Does that make sense? We will move it in a minute to the front. Sound good? Is everybody good on that? So now z positive, x positive. We hit check mark. And now that's what we're off of. Except when I look at it, where does it really need to go? It needs to shift, doesn't it? To the front of the part instead of the back of the part. You can't, they're the world. So how would I create a new one? I could duplicate. Right click. No, dude, no. It drives, does everybody see how? Yes, this drives me nuts. This has nothing to do with, it's just the XY plane we're on. So we're on the XY plane to program on there now, if that makes sense. This totally confuses people, but the Z is pointed along it. I'll show you how to double check that here in a second. Does that make sense? But don't look at this and be like, oh man, my X is pointing down my part. This has nothing to do with it. This has to do with your construction plane. So what I'm going to do, where am I going to shift this one? I would shift it to the front of the part, right? So I literally have to bring it up to over to the front over here. So bloop, bloop. So I move is the x-axis in the world. Isn't that crazy? Even though it's along the z, it's so annoying. So now if I want to program off that, I make it equals, and I'm good to go. So now what we're going to do is we're going to go to our levels, and we're going to create the geometry we need to program off of it. Believe it or not, you don't program off of a solid model. You program off of a 2D wireframe that's half the profile, like we're doing a revolve. So we have to use the solid model. Now that we got the axes all set up, we have to use the solid model to generate that revolve for us. It's going to do like a reverse revolve. It's called the spin profile. So what I'm going to do is I'm going to call my level right here. I'm going to go ahead and create a new level. I'm going to call it 2. I'm going to call it wireframe lathe profile. That's actually what it is. Sound good? And I'm going to make sure it's check marked, so I'm creating geometry on there. So I'm going to use this solid model, and it's going to create me some wireframe geometry to program off of. You don't actually program off models with lathes. You do in Fusion. So next, I want you to go to wireframe. Oh, wait. It might be model prep. Wait. No, it's wireframe. And it's called turn profile. What do you think that creates? A 2D profile to turn to. So you bring in your model, you get your axes set up, and then you're going to create a turn profile. That's what we're doing. So when I pick turn profile, what am I going to pick? The whole model in selection. Now let's look at this real quick. It can spin it different ways, but we want X positive, Z positive, so we want the upper profile. Cool? Apartment flooded? Wait, not quite, that's good. Fixed it. Gotta call that water pouring it. We want to spin it, we're not slicing it. Slicing is like a 3D model, like the other way. So when I spin it, I press check mark. Did you see the little wireframe that occurred on the top of my part? How can I show just the wireframe? Thank you. So I'm going to go up here. I'm going to eyeball. There it is. Everybody see that? That's all I need to program. Yes.
If you update your part, will this wireframe update?
No.
Will it just stay whatever?
No, you just bring in a new wireframe or take your wireframe. So now what we've got, That way we got revisions in the back. You got revision history. You just keep adding new revisions and you got it. I like revision history, trust me. I don't like how Fusion overwrites everything and you're like, oh, well, I'd rather have had that too much. You could save it that way, but it's a pain. So with this, check this out. If I go to my level or I go to my planes, I make sure my deposit of what I'm programming off of is good to go. Oh, does that lock it so you can't? Nice. You can lock the planes now so you can't move them. That's a new thing. So I just locked that one. But anyways, when I come back over here, I can go to home. I can go to analyze entity. I could grab that diameter right there. Does everybody see how I have a D and a Z? My D is 0.625 because that's the diameter of this line. And it starts at a -1/8 of an inch back because that's the radius value from the Z0. And then it ends to -125 back, -375 back. That's the line length. It's a 1/4 inch long. Does that make sense? If you don't get these, I can help you transform your geometry to the right location after programming. Sound good? But this is what you have to have. Let's check some other points. So if I checked like this line back there, the diameter is 1.48 and it goes back to 0.3725 right before the chamfer. Does everybody understand how I'm checking my geometry to make sure the D values work and the Z value in there? Because Z0 is the front, right? So like if I click this line, D0 is where it starts and it goes to 0.375 before it swings the radius. We're doing good. Z's both 0. Do you have questions or are you just kind of staring at me? We're good. We're good. Cool. So now, did everybody get the values like that was checking them? Yeah.
So if your values aren't that,
You most likely, if your values aren't like that for the Z, you most likely didn't shift it down here to the front. You're probably back here still. Or so we can move that later. It's not a big deal. That's a moving thing. Is everybody good? So now, one thing I'm going to have you delete because I don't want you accidentally picking the bottom of this line to go ahead and cut off, but instead of the top of the line, it's happened. It's scary. It rapids straight into the center line, but it's in 5% rapid, so you think it's cutting, but it's like cutting really aggressively and yeah, bad stuff. So we're going to delete that. Sound good? We don't need that. Everything else we need, but we didn't need an accidental point in the center line on the back of the part we could accidentally pick off. That's all. Cool? Now, another thing I wanted to do is this is a chamfer, right? We're going to leave that there, but I also want to kind of go ahead and have a little bit more material. So where is it? Give me a second. Wireframe. It's going to be modify length. I click on the line right there and I put in the chamfer value, 0.025. And I hit check mark. So I just basically I'm going to end there. So I can end there on a turning path and I can have a chamfer point. Does that make sense? So that's all I did with my wireframe. I just made it so it went a little bit longer. Do you want to see that again? It's called modify length. If you accidentally click past the midpoint on this side, it modifies it the other way. It looks at the midpoint of the line and goes that way or that way. Oh, geez. Shorten. There we go. Okay. Is everybody good? See how so this type of CAD is how I learned CAD. Like all these simple tools like this back, it wasn't 3D. It was a totally different world. We didn't have internet barely. Definitely not like we do now. So it would take like 2 minutes to download a picture. Anyways, not joking. All right. So you think we're ready to program? Come on. Yeah. Yay, I gave you donuts. You're supposed to get excited. Those of you that were late, sorry, that's your problem. So what we've got here is what do we have to do now in order to start programming? This is just like the mill now. We got the geometry all set up, right? So we did the CAD part of CAD CAM programming. What else do we need? Toolpaths. But how do I get them? They're like, there's toolpaths. There's nothing here.
select a machine.
I gotta select a machine. So we're gonna go over here to machine, and this time I'm gonna pick out lathe. It's the first time I've ever opened 2026, actually. So this is a great day. So we're going to go ahead. We're going to hit manage list. What one are we not going to pick in the US? Yep, not MM. So we're going to add the lathe one over there. We're going to hit check mark. So we now know we've got lathe. So this is a lathe. It's a piece of stock and a cutting tool, if you're wondering what it is. That's what the icon is. So there we go. Cool. We could do a stock model on this, but I'm not going to spend the time to do that. I'm just going to put in regular stock. So in fact, I'm going to go back to my levels and I'm going to show my solid model because I think it looks cool. And what I want to do, so I can have my, do you see how I have my wire frame now on my solid model? I'm just going to leave the solid model up there and pick wireframe only. Just want to point that out. So the solid model does nothing for us other than look shiny. So back here to toolpaths. So now, do you remember opening up this properties box? And we could go ahead and add stock. Is everybody good on that? So if I add stock, this is the old school menu. That's good. I'm used to this one. So let's talk about this. Let's go to properties. It's a left spindle when we're standing in front of it. The spindle's on the left. Now, what's the diameter that you told me earlier in the day? Yep, so 1.5 OD. What's the length? What was our pull out or stick out length? Add those two numbers. 4.25. Oh, what's position along the z-axis? Is it negative 25 thou? No. What is it? It's positive 25 thou. You know why? The part's negative 25 thou. The stock's, actually the part's 0. So the stock's 25 thou in front of 0. Does that make sense? I didn't at first to me. I had to talk it out in my head while I was explaining it. So does everybody understand how the stock works right here? Make sense? Yes. It's 4.25. Because it's 375.5 inch. Oh, you thought that was a 1. Yeah, that's my bad. Those are my bad extension lines with no dimension lines, and then it went downhill from there. So when I hit check mark, check this out too. Would it be cool if we ran into the chuck jaws? Definitely not. So we're gonna model them. So we go to properties. If you wanted to get crazy, you could sit there and fill out the data table and make yourself a little steps of chuck jaws. Sound good? What we're going to do is we're going to just go to parameters and we're going to open them up the 1.5 in diameter and we're going to put them back there at basically 4.25. What's going to look funny about this model? It's not going to hold on to any stock in the chuck jaws. So when I hit check mark, I'm going to go back to my properties on my stock. I'm going to just say 6 right there. Sound good? So it looks like it's inside the chuck jaws and we don't think, well, wow, that's magic. So I hit check mark, check mark. What's wrong with my chuck jaws, everybody? I know exactly what I didn't do. I go to properties. Does anybody see what's wrong with it? Oops, it's over here. I did 6 because you look at you see my stock on the screen now? It's like I put some stock in the back in the chuck. But what did I not do on this value up here? Why are they in front, not behind? What would make a difference? Notice my jaws are way in front of my part. What gives me that here? Probably highlighted yellow. Which one is it? It's a 4 point. What's wrong with it? Negative, right? I didn't put the negative sign in front of it. And then so now the chuck, that's what it looks like. Does that make sense? And look, we could shade it. Woo, they're pretty now. Does this make sense, everybody? So I would definitely model where your jaws are on the lathe because those are hardened. They don't cut. So, you got any questions? Are we doing okay? I can show you settings again too. Yeah, I can show you stuff. You got it if you need help.
I think I got it. Mine just crashed, so I would.
Oh, that sucks. So sorry. Yeah, so like I can show anybody anything if you want to see it again. It's kind of just like an impromptu video, but hopefully you can hear me from over here. Yeah.
You did the job.
Sorry.
Things like-
Yeah. So do you mean the these jaws?
Yeah.
Yeah, definitely. So it's under the stock setup. It's under the jaws, the properties. I go over here to parameters, and it's -4.25. I put positive, I think, one of mine, and then you want to open them up 1.5. So what it's basically doing, it's putting these fake, like this first page, the geometry, you can add any amount of steps that you want right there. It's a little parametric design. And you can actually measure your chuck jaws, but I just know we don't want to go past the chuck jaw at all. So we should be good. So when I hit check mark, the first one's the stock, the second one's the chuck jaws, and you want to be off your stock plane up here, whatever we set up, our D positive, Z positive, whatever it's called at that point. So check mark. This, yeah, the stock parameters. Which, like tool or here? Jaw properties or parameters. And if you don't have your jaws, it's not a big deal. That's more for simulation. I know we're not going to crash into them. Well, I don't know that for you, but I know that I'm not. So you should know. Yes, you understand, right? Hopefully you enjoyed the class. So, all right. I think we're now ready to check this out. So we got virtual stock all around our part. Does everybody see that? We're ready to pretty much cut this solid model out of this plane of shaded stock. So to do this, now that we've got a lathe post, look at that. It gives me milling tool paths and turning. Why would it give me milling? We could have a live tooling lathe and have it come in and do milling operations. I'm going to do a demo on that next week. When we get back from Thanksgiving break, I'll show you how that works, how live tooling works. So then we're going to go not to milling at all. We're going to go to turning. There's some cool stuff you can do here. So with this, we've got something called, I'm going to show you this. I don't normally do this, but I'm going to show it to you. It's called manual entry. What do you think you do with manual entry? You write whatever G code you want to show up on the line before that tool path or whatnot. So what I like to do, I know it's already going to probably do it, but I would like to do G28 just to show you that and then that it's a manual entry. Does that make sense? So you can either put it in as a comment. So if you wanted to comment your program a bunch so people saw comments, you put it in as a comment, you write a comment there and it posts a comment in your code. That's what manual entry does. Also, I'm going to put it in as a code. I'm just going to write G28 so it basically returns the machine to home first thing before the program even starts. It probably does that in the post automatically, but I'm just showing you what manual entry is. We didn't really need to do that. So if you're at home doing this, don't have to do that. I just wanted to show you what manual entry was. Cool? All right, so there's other cool things too. Point would bring you to a point if you wanted to on the lathe at any time. We don't care about that. We care about facing. Is everybody good? Face. This time you don't pick geometry with face. It uses the stock. And it's all about building tools now. That's what this is all going to be about. So we're going to stop and talk a little bit about this. Maybe I can put the camera on the board. See what I can do here real quick. Video camera. Oh, it's going to blur out the background. We're good. It's too high tech for me right now. So the lathe, we've got 4 different types of tools in terms of turn and face. So you see how we've got OD right. I'm just going to look at that. So OD turn. OD right. We turn, because when we turn, we go basically with the right hand tool from the tailstock to the spindle. Do you see right next to it? What does it say? OD left. Don't worry about the rough and finish. That's just the insert's kind of designed to do. So OD finish. OD turn. And then basically we're gonna call it back. Why is it a back turning tool? What's back turning? So we're going from the spindle to the tailstock this time. So we're cutting, it's a left-handed tool. So this is gonna be a right-handed tool. This is gonna be a left-handed. Doing good? Okay. Next, we've got rough right. But do you see how the tool, and then we have rough left? What do you think these tools are? Does anybody know? They're boring bars. So that makes them an ID turn, ID bore. Technically, it's an ID turning tool. This is inside diameter turn. So then ID turn back. So we've got 4 types of tools right now. We've got regular turning, we got back turning, we got boring, and then we got back boring. It all has to do with how you hold the tool holder. I can have the same insert, I can have the same C and MG, I just hold it different ways. Making sense? So we've got this turning tool right here. We're gonna modify this one to make it work. Sound good? We're gonna take this tool 1, we're gonna double click on it. And we're gonna start right here. It's either a turning, a boring tool, a threading tool, or a grooving / part off tool. Don't worry about custom. Or it could be a drill, a center tool. Question.
For your inner diameter.
Say it again.
For your
What do you mean? It has to do with the way that I don't know what you're talking about. You have to ask. No. I'm confused. Sorry. Like I don't what do you mean you flip your R and you're out? What do you mean? We have so you're traveling, the way the rake is or the lead angles are on your insert is traveling either from the spindle to the tailstock for back boring, or it's this way or the other way if we're regular boring. I'm still kind of confused on but the tool is like either inside the diameter or on the outside. Cool. Yeah. Ask it a different way if you could. Like
Yeah, but it seems like I was thinking about like forward and back.
I wouldn't look at just how they orient these. These are more like pictures. Sound good if that's maybe what's confusing you. These ones kind of look right, but like this one isn't really like set up the way right and left the way it should work in the regular world. But cool. Okay, so what we're going to do is we are going to set up this tool. I'm going to come back over here. So we are going to be turning, right? So it's a turning tool. After you go to there, how do these inserts work? Is there some sort of universal designation or something like that? There is. So we know that. What do we have? How do we get this? Where do we get this information from? Where's all of our tooling that we're going to put into this? Where's that located? Yeah, the PDF. So we'll go find that real quick. Move the Zoom stuff out of the way. Here now. Move right here. So last week, actually it's a Word document. I already probably have it right here. But brought this out, right? So we have a CNMG 432B 1/32 nose radius, right? Because the 2 back here tells us that. OD face turn tool. So we got to set that up. We got to set up a VNMG 432B. We got to set up an 095 grooving tool. Oh no, it is 095. Cool. And then we got a 125 part off tool right there. So we're going to set up this first tool, moving back over here. Yeah, here, back here. So when we're in here, I'm gonna go face. I'm gonna double click on the tool. It's a turning tool, right? And what I can do is I know that it's a C. Look at that. A, C. Does everybody see that? Or I could grab Get Insert and grab a CNMG 432 from a catalog. I could actually go right here as well. The Select catalog. Go grab the ISCAR catalogs, the Kennametal. Look at the Sandvik catalogs. So they all have catalogs from the manufacturers in here. So, like, so if I was going to go with, where's Kennametal? A Kennametal. I could say Get Insert and look, every single part number for Kennametal is right there. You see that? So I don't even need to build my tools. I just use the manufacturer's part number that's already built in here. But I'm going to build a generic one. I'm not going to use the manufacturers. So this is just a name up here, the insert name. I call it CNMG 432. So that's what it is. So we got C, N. We doing good? M is the tolerance, so we're not worried about a tolerance. It thinks it's perfect, so it doesn't have an M. And then we got G is the mounting method. 4 is 4/8, if you remember, which is a ½ inch inscribed circle. Remember we learned all this? Basically, 3 is the thickness, 3/16. It goes 8/16 and then 64ths. So the 2 is 2/64, which is 1/32. So we set up all the correct sizes. So when we get into our cutter comp, it can go ahead and under and overcut the right amounts. Cool? Are you good on the insert? The holder is not as important. It's important if you're going to rub it on the back of the part, but we have 5-degree holders, so you don't need to change anything. We have L holders. So the standard pretty much, the 5-degree L holder. But the last thing you got to change back here is important, the speeds and feeds. So we're going to run like 12 thou. We're going to work that lathe, all 7.5 horsepower of it. So 12 thou plunge and feed. It doesn't plunge really on a lathe. So just plunge and feed are the same things. What's the difference between inch per rev and inch per minute? Which one do we want to run? Inch per rev, right? Because we're not drilling or doing anything like that. We're going to just run chip loads. So we'll run a constant surface speed of 650. And basically, when I hit check mark, it's going to grab those parameters and it's going to use the parameters there. Our max spindle speed is 2,000, not 10,000 for the whole project. Sound good? So I didn't catch that, but right here, that'll be 10,000. So it's tool 1, 12 thou chip load, 650 spindle speed, max out at 2,000. If I come over here to the face parameters, it's using the stock to figure out the size of the, do you see that? You can either select points or you can just give it your stock because it knows you're going to face your stock. Starts a little bit bigger than the stock and then 100 thou bigger than the stock right here. And we are not going to finish step over. We're going to rough step over and we're going to leave 5 thou for a finish pass. Sound good? We're just kind of qualifying it at this point. We'll come back and finish it with 5 thou. So when I hit check mark, what happened? The toolpath came in and trimmed my stock down to 5 thou away from the surface. You see that? And what I can do is I got to be able to virtually simulate this somehow, right? So let's do it both ways. Let's click on the toolpaths. Let's hit back plot. I'm going to move it so it's more like a lathe like we have. So it's going to go down like this. See how the tool is now like this? So this is a slant bed when it looks like that. This is the tool room lathe when it looks like that. It's the only difference. Slant bed, tool room. Cool. So when I press play, oh wow, it's super slow. There's the speeds right here, but it's real touchy. All right, we faced and we retracted. We're good. We're not going to crash the lathe. Not today. We good? Does everybody understand that? Do you want to see the other simulation or you want to wait for a better tool path? Better tool path? Cool. All right, I'm ready to do this. What are we doing next? We faced it. What do we do now? Get a drink of water while you tell me. What's it called? No, we're not going to finish anymore. We're going to finish when we turn the whole thing. What do we do now? Let's go ahead and rough turn this thing, okay? We're going to rough turn, but we're going to stop right around. We're going to stop right here because we don't want to dive into the grooves here, but we do want to dive into the grooves up here. So we're going to split it up and we're going to rough the front half, then we're going to rough the back half with a sharper tool. So to do this, it might be easier to take off the solid model. I'm going to do that for us just because it's going to be easier to see. So I go to levels, we're going to hide that solid model, and I'm just going to see my wireframe that I'm programming off of. So what I'm going to do is I'm going to go to rough turn now. And I have a chain, right? I don't want to chain the whole thing, everybody. So I go to partial chain. Are we good? I want to rough from pretty much that radius to that radius. Does everybody see that? Green is start, red is stop. So I'm going to rough that area of the part. Are there any questions on that one? So when I hit check mark, does my tool change? No. So we're going to keep that same tool, same feeds and speeds, except this 10,000, I should have fixed that in the tool menu. It's 2,000. If you didn't touch that, nothing bad would happen. It'd be still at 2,000, the max of the machine. You doing okay? So next page, roughing. See how this is really easy. I saved the easiest for last. So we want to max this layout, right? We want to see it go to the yellow zone. I do. Everything, yeah. So 0.075. Didn't want to, you should have bought a smaller one. So 75 thou. I'm going to leave stock to come back for a finish pass. Does everybody go with that? Now, I'm going to click on plunge parameters to show you this. We are going to make sure we are not diving into grooves like this. No plunging allowed. Do you see that? On this toolpath, no plunging. It should be already by default. We should be good. So we'll hit check mark. Next, I'm going to hit check mark. It's going to rough my part. And look, my stock's starting to look like what my part's going to look like. Kind of cool. Has everybody got this so far? Are we doing okay? What's next? I got to rough again. So I'm going to plunge with a roughing tool and basically rough out this little radius in here. So in order to get in there, we have to go in here. We're going to rough. I'm going to rough, everybody watch this, from that line to that line. So it's the two flat lines, right? So the flat line, the beginning of the first flat line or horizontal to that horizontal line. Cool. When I hit check mark, I now no longer can use this tool. It would run the back edge of the tool into the part, I promise you. So I'm going to go down here a little bit. I'm just going to build tools that they already have. Instead of building one from brand, I could right click and build a brand new tool. I'm almost taught. I'm going to build a brand new tool because it seems that students have a hard time. Well, this tool 2121 is exactly what we want. 35-degree diamond, but students have a hard time. I don't know. They have a hard time building. Which one do you want me to do? Build a new tool or do you want me to just pick this one and change it? Build a new tool? Yeah, because we changed the last tool, right? So I'm going to build a new tool. So I right click, create tool. What type is it going to be? Turning. What type of insert? I'm going to go V and MG. So I grab a V, in, M is the tolerance, doesn't matter. G is the mounting. It's a 4, does it say a 432? Pretty sure it is. 4, 3, and then I got to make this a 1/32 too. Is everybody good? Then I go to the holder. The 5 degree. Oh, yeah, the 5 degree holder is what we got. I told you that. All of our holders are L holders. So the L holder. Then the parameters. It's not tool 21, it's tool 202. So tool 2 right here, right? Offset's 2. Supposed to be a joke. Now, because it's a sharp tool, do you see how the chip load's a lot less than it was on the last tool? I wouldn't run more than about 7 thou with this. So we're going to run 7 thou. And we're going to run a 650 spindle speed. And I'm good with that. So I'm going to hit check mark. I don't know. I thought it was right here originally. Maybe you don't. Maybe it isn't in the tool menu. I thought you could do it for that, but maybe it is in each individual tool menu. Because yeah, no, it would be in this parameters right here, and it's not. So cool. Yeah, I guess so. So you just have to do it every time right here. Okay. So 650, 2000. When I go to my rough, we are not going to do more than 25 thou depth of cut. And we're going to leave 10 thou stock. What do I got to do with my plunge parameters though? If I want to rough that radius out of there, what do I switch it to? I would say here, right? Plunge in both directions, X and Z. So I hit check mark. Last but not least, it's got default lead in and lead out values. These are lead in and lead out values. Everybody see these? It's 45 out. Well, if we lead in with the default, we come in like this and like gouges the whole part. So we got to modify how we're going to lead in and lead out to come in and plunge into there. So we do that by clicking on lead in and lead out. I go to my lead ins and I think I'm going to pick perpendicular. It's perpendicular to the surface. I'm going to leave the lead out and see if it barks at me. We'll see. So I hit check mark, check mark. That didn't work. Give me a second. Do you see how it didn't go down? I got to figure out what I just did. I messed up. So I go back to parameters. It's not perpendicular, it's tangent. And hold on, maybe it's not tangent. Give me a second. Something's not set. That's really weird. Tangent to it. Lead in, lead out, tangent. One. You know what? It might be the 3 degree. Hold on. I might have the wrong. I might give you the wrong holder. You see how my holder looks funny? Everybody, look at my holder right here. You see how the insert's inside of it? There's a problem. That's why it's crashing and saying it can't do it. Go to the 3 degree. Go to the 3 degree holder. Hit check mark. Give it a second. Let me look at this. I messed up. It's not a 5 degree holder. It's a 3 degree holder. And rough parameters. Plunge is good. Lead in, lead out. I'm going to go perpendicular. And it is perpendicular. I'm so sorry. So that's what I do when I program off the top of my head, right? Just make mistakes. So let's go back and review this. Sound good, everybody? To see how it over and undercuts it, by the way? Like we come over here, like it's really close to the insert. But here we go. So if I go to my parameters, it's going to be lead in and lead outs are perpendicular. I was right the first time. My whole issue was when my tool holder, I gave it a 5 degree holder and it stuck the insert inside of it and crashed it. So give it the 3 degree holder. instead of the 5-degree holder. So check mark, and it should rough it out like you see right there. Questions? Got it? So we did, are there any questions on roughing before I go to finish? No? So there's two ways to do the finish toolpath. One, you could break it up into two pieces, but I don't like that. So what I'm going to do is I'm going to create a finished toolpath layer or level. Sound good? So I can just create one toolpath over it and call it good. It's going to be the cleanest way to do it. So where do I go to create that? I go to levels. I press plus. I'm going to add this. I'm going to call it finish profile. Cool. Now, what's in my way are these toolpaths. So I'm going to hide them. There we go. Now that I've got them hidden, what I want to do is I want to go to transform. I'm going to go ahead. I'm going to translate to plane. Does this make sense? I'm going to translate this piece, this piece, this piece, this piece. I'm going to stop there. I'm going to go to this piece, this one, this one. What am I getting rid of? What did I just get rid of by just transforming just those pieces right there? The grooves. I want to get something where I can skip over the grooves and I can still do undercut, so I can undercut this and not undercut that in one toolpath. So when I hit in selection, I'm going to copy it to I want to keep it on. I want to just, it's the same plane. I don't want to even, I should have just transformed to the same plane, but that's fine. There we go. There we go. So now I'm able to go to my levels and, oh, did I not put it on the finished profile plane? I press Control Z there. I messed that up too. We're just going to translate onto its own plane. I don't know why it didn't go from my one to the other. So we're going to hit translate, not to plane. We shouldn't have done plane. That's my bad. Regular translate. So we're going to translate those entities and those entities. Cool. In selection, I'm going to copy one. There it is. Check mark. Now I don't know why they're not putting it on that plane. Are yours putting it on that plane when it does that? Okay. Control Z one more time. So 2025 doesn't do that? Or it is? Yours copied it onto your plane? Didn't? That's just really weird. So how else we could do that is we could just basically go hide this other level real quick. Sorry about this. We go back to the model real quick, turn that on. We go to wireframe, turn profile, and we just hit in selection. We hit check mark. We go back and hide that. Now I've got the finished profile ready to go, and I didn't need any of this, so I just drag a box around it. That was way easier, right? Than me messing up transform twice. You want to see it again? Yeah, yeah. So Control Z a bunch for me. So I'm back to where, so check this out. I have a finished profile play level. You got that with 0 on it, and it's your active level. I show the solid model. Then I go to turn profile. I click on the profile, I hit in selection, check mark, then I go back and hide the solid model again. So I created 37 entities real quick that way. Did you catch it? Perfect. Then I don't need this. I delete that and I drag a box around all these grooves because I don't want any of these grooves. And that line I don't need. All I need to do is connect a line together here. Does that make sense? So I go line endpoints. I go from that edge to that edge. Escape. That's what you need right there. Oh, that was real difficult actually to get to that point, right? So I want one full turn profile so I can skip the grooves, but I can undercut up here. Make sense? That's all I was going after. And I really messed it up with transform. It bothers me. Yeah. Yeah. You don't really need the back. Yeah. You should extend the back. No, I'll show you why. Don't need to extend the back chamfer part. It's in the toolpath. So I I wanted that there for the part off point on the other piece. So I'll show you why. Only on part off is why I extended it. So has everybody got this? Are we good? What do I gotta do now? Finish toolpath. Does everybody see how I have 10 thou left on my stock? Yeah, no? Cool. So if I go back to turning, I pick finish. I'm gonna pick full chain this time and go, oh no, full chain because it'll go down the chain. It'll go down the chamfer. So partial chain from there to, don't pick the chamfer there. It'll go down, it'll dive down it and it won't look good. Maybe you'll think it will, who knows. So when I hit check mark, did my tool change between roughing and finishing for tool 2? No. So I have my same finishing tool. Just change your max spindle speed just so it matches 2000, whatever, if it's a 10. Now your finish parameters. Finish step over, we're only going to do one pass, so the step over is meaningless. Sound good? So we're going to do one pass. We're going to do lead in and lead out. I like to lead in. I have 100 thou length. We're good there. Lead out. I like to hit extend, and I extended 150 thou. That's the part off tool in the chamfer. The part off tool is 1/8 of an inch, so we're going 1/8 of an inch past the back plus the chamfer value of where our line is. So we cleared up some stock for the part off tool to come in and basically part off like 20 thou. Good? So when I hit check mark there and check mark, why didn't it? Oh yeah, forgot one other button. Why didn't it follow into the groove? We're right over it. Why? I got to hit plunge parameters, right? So I go back into my toolpath. I go to parameter. I go right over here to plunge parameter. I got to turn that on. It's probably a safe thing to keep it off. So we got that on. Now check mark, check mark. Wait a minute, my toolpath's going into my part. You see that? But wait, the profile looks perfect. What's going on with that? The radius of the insert, that's that theoretical tooltip. Do you see how it goes? Could you imagine mathematically having to calculate that if you were, no, it would suck. So we just go ahead and use the cam for the cutter comp. Sound good? So what it's doing is it's coming in and it needs a nub here sometimes. How do I not leave a nub? We're going to go ahead and we're going to go back into the finish pass. We're going to go into our lead in and lead out. We are going to extend it. I'm going to do 0.75. It's like 0.6 something, whatever the radius is, right? It's the diameter value of it. So I do that. I hit check mark. And it's going to start it a little bit before center to account for that radius of the tool. Hopefully we won't have a nub in the front. Probably will now that I said it, right? Are you good? It's your last project. I think so. Last required project. So now if I want to do grooves, what do I need showing? The grooves. So I go to that level. That level was just to finish it. And I go back to my wireframe 2. Make it checked. show it, I would hide my wireframe 1 so you don't accidentally pick it. And these are the chamfers I was talking about. You wanted to put them in there. If you didn't, guess where you're going? You're going to wireframe and you're going to, let me move this out of the way. Chamfer entities. You see that? And you put little 10 thou chamfers on your wireframe. I'll never know the difference. Actually, I will because your drawing didn't have it, but whatever. So with this, the groove is actually the easiest thing to do. We've got to go ahead and go to turning. Which tool path am I going to pick? Louder. Groove. All right. So we're going to pick groove. Guess what? You're going to screw this up royally unless you hit multiple chains right now. This is like the big thing that students do. They're like, oh yeah, I'm going to just go chain it real quick. They don't hit multiple chains and it turns the diameter we just turned and it looks horrible. So multiple chains, we're going to make multiple grooves. 4. So when I hit check mark, I'm going to pick partial chain. You know why? We're partial chaining grooves. In fact, what makes up the groove? That to there. That's the groove. Does everybody see that? Do you see this button that says in chain? You click that and then you make another chain over here. You go green to red. In chain. Green to red. In chain. Do you need me to say it again? Oliver wants me to. So green to red. In chain. We're done. So do not pick the top lines. What's it going to do when you pick the top line? It's going to try to turn the top line with the grooving tool, and it does not look as good as the turning tool. Does not. Doesn't have a radius as big of one. So when I hit check mark now, I've got to build a grooving tool. Guess what I'm going to do? I'm just going to take their OD Groove Center tool and build it off of that one. Sound good? The only thing that matters is the groove's geometry, the insert's geometry, so it makes it the right size. It's a neutral tool. It can go both ways. It basically stabs at it to rough, and then it turns with it a little bit to finish. So when I double click on tool 41, what matters is this insert's thickness, this D value right here, and the C value if you have any type of radius on yours. So I'll tell you right now, we're 0.95. I'm pretty sure we might change that today. And my C value is like 5 thou, a really small radius on it. Where do you get this information? From the manufacturer. Whenever you buy the tool, it tells you what sizes things are. You put them in there. Cool. So now this is a right-handed part off tool. See how it's got a little rake to it? So now the holder doesn't matter. Actually, the holder matters in that your C, is it the C value right here? This value right here, C? This has to be deeper than your groove, or else it'll say you crashed it in the simulation. Like I've been telling you, holders don't matter all year, but Jeremy made something and the holder was crashing and we couldn't figure it out because I told him just to whatever holder in. So it's taking out the sphere on that 3-axis part, but it didn't do it, right? Cool. So yeah, holders are important in a certain sense. So cool. So now next, parameters. It's tool 3. Offsets 3. Station 3. Back offset 3. Only thing that matter are these two. These are for other types of lathes. Now, feed rate, we're gonna go 3 thou. And we're gonna run constant surface speed of 650. So when I hit check mark, I've got my tool number 3 set up to go. Oh, it's got a finish spindle speed. It doesn't like to go very fast when it's turning, so I'm gonna do a finish spindle speed of 750. So 2,000 max, but when I finish, I'm going to slow it down and allow it to finish nice and slow when turning. So with that, you do nothing else. Go ahead. In a minute. when I'm done with the toolpath. Cool. So groove, I don't do anything. I'm going to cut at 90. Does that make sense? Groove at 90. You could groove it at another angle if you're into that. It's usually 90. So groove rough. This you do need to change. You don't want to use 75% of your tool when you're roughing. Let's use 25. Actually, let's use 30. Then it's going to leave 5 thou to finish. This is roughing. So when I go over to finish, you can decide how you want it to clean up the pocket. It doesn't matter for right now. I'm just going to press check mark and I'm going to make 4 grooves. So my part looks grooved, but the question was, what type of geometry did you pick? So if I go back to my geometry, they look like that. Arrows don't matter. I clicked multiple chains and I made 4 chains. I clicked green to start over here and then to stop right there. And if you don't pick like over here, it starts over here. So you got to kind of pick like in this area right here where my pointer is. And you got to kind of pick like up here right there. It's weird. So I'm going to pick another groove toolpath to show this real quick. Groove, multiple chains, check mark. I'm going to grab partial chain. I'm going to grab there to there, next, there to there, next, and I kept going. Did that help? I don't know about that. I'll have to look at that later. So the part's pretty much finished. Do you agree? What do we got to do last? Take the part off. So we're going to part it off from the bar stock. Now, this is why I had you draw this line right here or extend this line. So you don't accidentally pick down here. You got to pick the end of the part. Cool? That's why I was like, let's extend it now so we have that when we're ready to part off. And check this out. We turned with our finish tool, so we have a little bit of nice machine stock. We're going to bring the part off tool in too. So to part off, what tool path is it? Cut off. So part off is cut off. I was just waiting to see if you got, So now you see where it says select cutoff boundary point. This is not where you wanted to pick down here. You wanted to pick right here. Everybody understand? The end of our part, 3.75. Now, they have a part off tool that we're just going to go ahead and mess with. So if you go all the way to the bottom, we are going to pick the right tool. 151 offsets 151. Tool 151, 151. Cool. We're going to double click on that one. The E is the thickness. That's correct. We don't need to do anything here. The thickness is what mattered. Sound good? Now, technically C is actually 0. So we'll make it right. C is technically 0. And then I guess, where's the radius? They don't have a radius. Oh yeah, D. D is like 0.005. So maybe we changed a couple of things right there. I wouldn't be able to tell, like looking at your part. You good? So then we go to holder. We're good. What matters here is the C is at least the radius value of what you're parting off, right? So we're at 3 inches. We're going to be great. C is actually way longer than what we need. We're good. Now, parameters here, it's tool 4. We're going to part off right here. We're going to run an RPM with it at 500. I don't want to go faster than 500. I just don't really want it shooting around. Kinetic energy is a little crazy sometimes, depending on what it hits. Are we good? So I hit check mark. Now I got tool 4. Look at that. I got tools 1, 3, and 4 for grooving. I'm going to go ahead and max spindle speed, 500 here. To match my 500 RPM, it wouldn't make a difference. It'd still be 500 RPM. You good? Now, cutoff parameters. What do I like to do to break chips? Peck. So to peck, you got to click this button that says peck. And you got to not mess this up. You come over here. You are going to peck. You're going to go like 75 thou pecks. Now, you're going to retract when you peck, right? Are you going to go to absolute zero? So incrementally retract like 25 thou. Or actually just do 10 thou to be fine. People leave absolute and zero on there. So when it go the first peck, it goes right into the center of the part. I think it's funny because they don't understand what absolute zero is. It's in the center of your part. It's kind of cool. You can go to absolute though and pull out the same point every time is what they're doing there. So that one again, let's look at this. It's like how you can really mess this up. It's not absolute zero, it's not absolute 10 thou, it's incremental 10 thou. Cool. A lot of times people do it, they didn't even realize it because they were in 5% rapid and just sent it. And they're like, oh yeah, I chopped it off. So what does it have on the back of the part? Oh, look at this button, chamfer. Yeah, and probably a nub too, Nico. It's probably got both. So with the chamfer, if I hit parameters, it doesn't always work right. The tool flexes a lot of the time. But I could say that I wanted a 25 thou chamfer right here. It's going to say it crashes because you're not supposed to turn with a part off tool, but we're going to say we don't care. So we're going to press check mark, check mark. See how it says collision with stock? Because I'm doing a chamfer right there with it. Whatever, hit check mark. It'll do it. So what it did is it came in and do you see the little chamfer with the part off tool? Kind of works. You'll see it doesn't really. We tried it though. So with that, I can go to my toolpath group. I could go to my verify. We out of time. Oh, we're kicking butt. We're doing great. And then I can move the zoom out of the way. Maybe minimize that real quick. There it is. It's hiding back there. Zoom out. Oh, look at my chuck and my stock. That's great. All parametric. So I'm going to make it a tool room lathe by doing this. And we'll slow it down. Cool. It disappears at the end because it falls off. It drives me nuts because you can never see the part afterwards. It's like, I want to see the part. So how do you get it not to disappear? You don't simulate the cutoff. So I think we're good there. What do you think? I was good. I was good with it. So we'll go over here. And the next step, let's go to the PowerPoint and see if I forgot anything. So I left us at the diameter system. We got the appropriate planes, right? We got a D positive, Z positive, because we're programming in the upper half, diameter positive, Z positive in this direction. So if you look at the old school master cam, it looked like this, where you had the lathe right there. Now it's underneath this plus button in the 2026. I found that out. So then we created a lathe, D positive, Z positive, right? And then we got a post processor for it. Is everybody good with that? And we got our wireframe there. So we have wireframe level. Then we created that turn profile. And we got our post processor. We added stock. So when we added that stock, we added 25 thou in front of our part. Then we created the face toolpath that goes through the parameters there. The feeds and speeds might be a little bit different. Stuff might be slightly different, but it'll work. I promise. I program everything in front of you on the fly. I don't look at notes or anything like that. So then we got rough turn. That's what it should look like right afterwards. We got finish turn. That's what it should, or rough, I'm sorry, second rough. That's what it looks like. Then finish turn. I broke the finish pass up into two here to show it to you. You could do that if you didn't want to draw your own level. You could go ahead and do one finish and then another finish. It just backs up. It's better to do one fluid finish all the way through. It's faster. Then we did the chain. This is why people mess up because I have chain selected here. It's multiple chains. This is what I want you to realize. It's multiple chains right there. It's not what's selected on the radio button right here. It's probably why people mess up. Here's our chain. It can go either way, green to red. There's the settings. Then it makes the grooves, right? And then we have the part off with PEC. There's the chamfer for it. And we simulate it. Now we need code. I forgot to change these dates. It's okay. We'll fix that. These are just going to scare you. Sound good? It's the end of the week on dead week. So it's Thursday. You have to have the cam in. So you got to get your cam approved by me by next not Thursday of next the 5th, the 4th. It's the 4th, Thursday the 4th. It's on Canvas. I already put the right dates on Canvas. I didn't put it up here. I'm sorry. So this is due December the 4th by 1:30 p.m. Fair enough. You got to have your master cam approved by me and be ready to run on the lathe. There's plenty of time to do that by then. But I have a couple other things to do in between them, but that's other classes. Go ahead.
Let's say we wanted to drill into the part.
We would drill in. I'll show you that in a second.
Okay.
We would drill. It wouldn't be hard at all.
All right.
We would just use the drill toolpath and try it out. Like literally, it says it gives you depth after you pick a center point on the front of the part. It's so simple. Like drilling is like so simple. And I'll help you set up a drill if you want to drill it. Yeah. Anybody who wants to drill in the part, we can drill in the part. So it's your cam program is due by 1:30 on the 4th. And then the 5th, you got to get it by 5 p.m. But you're also gonna have to inspect it by 5 p.m. So don't think you're gonna be running it on the 4 o'clock on the. Well, you can probably run it at 4 o'clock and inspect it by 5. If you had your stuff together, like, oh, you're not. But don't be that person. That's the last day of school. Sound good? December 5th. That's when it's our last project. So with that, there's a YouTube video on us how to set it up. It went viral like in Europe on how to set up a tool room lathe. That's got like 40,000 views or something. It's probably got more than that by now. I did it in COVID, 41,000 views in COVID. It's kind of cool. I just came into the lab because I was bored and everybody's like wearing masks everywhere. I was like, I'm gonna go to the lab and do some videos in COVID, have a good time. And it just became fun. So, I mean, I came into work every day with that. It was a fun place to hang out. So no one was around. The campus was completely dead. Like I had a whole machine shop to myself during COVID. Delilah was just born, so I was taking her into the machine shop. It was fun. So she did more college than most people, like, because she sat there in Zoom. She's done like, it's pretty funny. So what we're going to do is we're going to take this and we're going to go downstairs. We're going to set it up and run it. So it's pretty much open for you guys to do whenever you want. Sound good? And then I'm going to come back up. I'm going to answer any questions you have on programming for Mastercam. We're going to come back tomorrow. We're going to learn about can cycles and how to make threads. And I'll probably go downstairs and cut a thread on the lathe just to show you how that works. Sound good? And then we'll do either live tooling lathes or it's micro machining / live tooling lathes on Thursday. And then we'll take a break. We'll come back and we'll do. I think there's live tooling then on the week back. We do micro machining that one day, and then test review on that other Thursday. Is that a question? That's not a question. So I'm going to need Jared's memory stick since you've given it to me every time. And how do I get code? We hit the G1 button, right? Everybody's gotten that figured out by now. Check mark. Thank you. So with this, I'm just going to throw it on the desktop. I'm going to have you look for some things. Desktop, save. So we know that these are giving me a hard time all year, right? My really long file extension that gives me an error when I load it in the CNC. So I'm going to delete that line of code. The rest of them aren't too long, that will be good, but I don't want them to know the date and time I posted and where my files are, so I'm just going to delete that. So now, what do I need to do here? We're going to call it 337. Sound good? We went 5, 6, 7. And we'll call it my name here. Whoops. Dude. It should have G28'd it. Yes. So why did it G28? Because I wrote it in there. I guess it doesn't do it in the post. So that's a good thing. It does it just to start off. Because you see when I was doing quick code, if it stops a tool path, it stops it right in front of it. So you usually like to G28, get the tool out of the way to switch tools. So that's why I did the manual entry first. If you didn't do that, it's not that big of a deal because at the end, it also G28s it, right?
There's a problem with the post, though. There's one problem. And the one problem is, let me look at this real quick. Let's just look at this together. It turns it on to 1460 RPM, puts the spindle speed clamp on, then turns on constant service speed. That's fine. It's 5 thou in front of the part at 1.7 diameter. We're doing good, right? Does everybody see how this works? Then it comes across to the negative 0.625 to count for the nose radius. Backs out to 100 thou in front of the part, then comes back up for its first depth of cut. So we're doing great. It does a bunch of depths of cut, a bunch of moves. Then at the end, it goes G28. What's U, V, and W? The ones we don't use because they're what type of programming code? Incremental versus absolute. Why would the lathe error out on a U, V, and W? Well, we're missing the W or V axis. We have X and Z, we don't have a Y axis. So the post puts it in for a Y axis lathe just in case. So what would we need at the minimum to delete in order for it to work? The Y or the V, the incremental in the Y, which is the V. What are we going to delete just so we don't ever have to remember which one am I going to delete? All of them. Sound good? So we're just going to say G28 M5. We're gonna get rid of the UVs and Ws because I told you we're not using incremental. Sound good? So literally you do that between every tool change. There's 4 of them. So if you go look, see how it says tool one offset 0? It basically releases the offsets, and then it goes to tool 2. Then if I go down, you'll see here's tool 2 offset 0. So it's right above where it clears the offsets. You just take out the UVW. M5 stops the spindle. It's kind of a little bit less scary when if you have to lift up in the hood and change the part, change the tool, then the spindles stop for the operator. If we didn't want it to stop, we could take that out. So what are we erasing? UVWs. What am I going to do? How am I going to look at you when you say, which one do I erase? I'm going to say, you aren't fucking listening, dude, because I've said it 4 times. UVWs, right? UVWs. It's okay if you ask me again. I'm good. I am going to be like, you weren't listening. So, but we're having a good time, I hope. So, okay. Maybe not. Maybe you just hate this. You're like, oh, I can't wait 4 more days. So maybe that's the way it is in fluids. Who knows? So we got UVWs done, but I just wanted everybody to see it does cancel the offsets to 0, 0 after every tool's done, just in case whoever's on it next, it's not their fault that you crashed it. So we're going to take this. I'm going to go File, Save As. I'm going to leave my laptop here. And we're going to go throw it on that. There it is on Jared's USB right out there. Project 3. We're going to go set up the lathe. I know we set it up last Monday. We're going to set it up again so it's set up for this project and everybody's ready to go. You might be able to cut today, some of you. Who knows? Anybody keep up? Somewhat? Close? No? Well, speaking of, let's stop the recording.